Hello and welcome. So, long before the silicon chip, way before the digital age, there was a spark. Today, we're going to talk about the glowing glass bulb that pretty much single-handedly invented electronics as we know it. It's a great question to ask. I mean, think about it. We live in this world of silent, powerful silicon chips, right? But the first electronic age, well, it wasn't silent at all. It glowed. One single invention laid the groundwork for everything, and I mean everything that came after. So what was it? Yep, the vacuum tube. You are looking at the forgotten ancestor of every single computer, phone, and television you've ever used. It might look like just a fancy light bulb, but its magic trick was simple and, honestly, revolutionary. It could take a tiny whisper of an electrical signal and turn it into a roar. All right, so here's our game plan. First, we'll get to know these magic glowing bulbs. Then, we'll dive into the super clever physics that make them tick. From there, we'll see how they literally built our modern world, watch as a new challenger appears on the scene, and finally, we'll find out the surprising places where that glow is still alive and kicking today. Okay, so for the entire first half of the 20th century, you have to understand if a device did anything electronic, I'm talking radios, telephone amplifiers, even the very first computers, it was powered by vacuum tubes. They were the essential building block of a brand new era. So how in the world did this magic bulb actually work? Well, it all kicks off with this weird physical phenomenon that, funnily enough, Thomas Edison noticed but didn't really know what to do with. It's called thermionic emission, and the idea is actually pretty simple. When you heat up a piece of metal inside a vacuum, like the filament in an old light bulb, it starts to boil off electrons. It creates this little cloud of negative charge just hanging out in space. And that effect, that's the absolute key to every single vacuum tube ever made. So, in 1904, a guy named John Ambrose Fleming figured out how to harness this. He put a second piece of metal, a plate, inside the bulb. Now check this out. When the plate was positive, it attracted that cloud of electrons, and boom, current flows. But when it was negative, it pushed them away, stopping the flow completely. He had basically created a one-way street for electricity, which he called a valve. This was huge, because it could turn that wavy AC current into pulsed DC current. A super crucial step, but it still couldn't make a signal any stronger. The real game changer came in 1907. Lee DeForest added a third piece to the puzzle. He put this mesh-like screen called a control grid right in the path of those electrons. And here's the genius part. By applying just a tiny little voltage to this grid, he could control a much larger current flowing from one end of the tube to the other. A small input signal on the grid created a huge, perfectly copied version of that signal on the output. And that was it. For the first time in human history, we had electronic amplification. And you really can't overstate this. The ability to amplify a faint signal into a powerful one was the spark that ignited the entire electronic age. It changed everything, and it changed things fast. And with amplification, the world just exploded with new tech. Suddenly, faint radio waves from miles away could fill a room with sound. You could send voices across whole continents over telephone lines. This is the tech that powered radar, which was absolutely decisive in World War II. It lit up the first television screens in people's living rooms. And yeah, it made the very first electronic computers possible. And this just perfectly illustrates the scale we're talking about. The legendary ENIAC computer, a machine that filled a massive room, was powered by 17,468 vacuum tubes. Just think about that. It also sucked down 150 kilowatts of power, enough to light up a small town, and it got incredibly hot. And right there, that points to the tube's biggest weaknesses. So yeah, as powerful as they were, vacuum tubes were kind of needy. They were big, fragile, super power-hungry, and hot. They burned out, just like old light bulbs. The world was ready for something better. And in 1947, at Bell Labs, scientists invented it. And that invention was the transistor. It was a revolution, in every sense of the word. I mean, this comparison here really says it all. It did the same jobs, amplifying and switching, but it was solid state. That means no moving parts, no heated filaments, no vacuum. It was tiny, tough, it ran cool on barely any power, and it was ridiculously reliable. For most things, the contest was over before it even started. And so, the great replacement began. Radios shrank from being big pieces of furniture to something you could stick in your pocket. Computers that once filled entire rooms could now sit on a desk, then in your lap, and, well, eventually, in your hand. This was the true dawn of the digital age. But, the story doesn't just end there. The vacuum tube wasn't completely wiped out. It just retreated. It found a few very specific niches where its unique properties still make it the absolute best tool for the job. And surprise, there's a really good chance you have a vacuum tube in your kitchen right this second. The magnetron that generates the waves in your microwave oven, that's a type of vacuum tube. They're also still the champs when it comes to generating huge amounts of power for major radio and TV broadcasts. And then there's the whole world of sound. Right, in high-end audio and especially for electric guitars, tubes are absolutely cherished. It's not about being perfectly accurate or sterile, it's all about character. The way a tube amplifier distorts the sound when you really push it hard, it creates this rich, warm, musically pleasing tone that tons of musicians and audiophiles still swear by. It's just a different feel. And what about reliability? I know I said they burn out, and many did, but some were built like tanks. The record holder is this one transmitter tube used by the BBC that ran continuously for over 232,000 hours. Let me put that in perspective for you. That's more than 26 years of nonstop operation. Incredible. So the vacuum tube, the glowing heart of that first electronic age, was this brilliant, world-changing device that was eventually replaced by something smaller, faster, and way more efficient. Its story is just this powerful reminder, right? Every dominant technology, no matter how revolutionary it seems, eventually passes the torch. And that just makes you wonder, what's going to one day replace the transistor?